Good morning, you guys. So we're going to be looking at classifying quadrilaterals using coordinate geometry. So the first video that I'm going to do is I'm simply just going to go through and we're going to review some quadrilaterals that you have been exposed to prior to this class. And then we're going to talk about um, how do we prove that these quadrilaterals really are quadrilaterals um, using coordinate geometry. And the second video is going to focus on me showing examples of that. All right, so let's look at what we've got going on here. All right, so we've got some types of quadrilaterals. These, some should be reviewed, and a couple of might be new. Okay. All right, so we've got a square, a rectangle, a parallelogram. You should definitely know those. And then we've got a rhombus, we've got a kite, and then we've got a trapezoid. All right, so what are our characteristics? So how do we classify, okay, how we classify quadrilaterals by their features, okay? So what are we looking for, okay? All right, so you can see here I've got a picture of a square. So things we know about the square. All four sides have equal length. All four angles are right angles, 90 degrees. You can see that that's marked here in the picture with that 90-degree angle. All right, opposite sides are parallel. Okay, that talks about their slope. And connected sides are perpendicular. When I say connected, meaning they're joined at a vertex. So they're joined at, in this particular example, a corner. Okay, so these connected sides are perpendicular. Okay, so now you've got to remember the definitions of parallel and perpendicular, and that relates to slope. Slope means parallel is the same slope, and when you have the slope and the two lines are perpendicular, you have opposite reciprocals. All right, a rectangle. All right, opposite sides are equal in length. Opposite sides are parallel, and connected sides are perpendicular. Okay, if all four sides are the same length, it's no longer a rectangle, it's a square. Okay, so everything's interconnected as well. All right, a parallelogram, okay? And you can see in the background of the slide, there's your example of a parallelogram, okay? Opposite sides are parallel, opposite sides are equal in length, but the connected sides are not perpendicular to each other. So if you look up here in these corners, okay, those are not right angles, okay? All right, a kite. So yes, the best way to imagine this shape is an actual kite. Okay, so when you are thinking about flying a kite, if you've ever seen Mary Poppins, okay, that's exactly what we're talking about. Okay, all right, pairs of connected sides are equal in length. All right, so what I'm talking about here, if you can see my mouse, okay, all right, so this pair right here, see that mark with that blue mark, that single mark? These two sides are equal in length, just like these two sides are equal in length. But I know these two sides are not equal. That's okay. It's these two that are connected that are equal. These two are connected and they're equal. All right, the diagonals. Now, we haven't talked about diagonals in any of the other shapes, but it's because a kite doesn't really have a lot of different things for me to work with because this is relating back to um, finding distance and finding slope. So diagonals, so you can see these dotted lines, okay, they're perpendicular, okay? Note that the opposite sides are not parallel, okay? Opposite sides are not parallel. All right, a rhombus. Okay, a rhombus is a parallelogram in which the length of all four sides are equal. Okay, so a parallelogram in which the length of all four sides are equal. Okay, so I think about a rhombus. I was always told as a student, just think about a square that's been sat on, because then now it's no longer a square. But if you sit on the square and you move the sides, okay, the side lengths have not changed. So you notice here in this big background image, okay, all four, okay, sides are equal. Now, because it's a parallelogram, okay, that means everything that was true about a parallelogram is true for a rhombus. So opposite sides are equal. Opposite sides are equal. Okay, opposite sides are parallel. Opposite sides are parallel. Okay, and we do not have right angles. Okay, so whatever you do to make yourself remember a rhombus, I was always told, okay, that it was a square that had been sat on. Okay, a trapezoid. Okay, trapezoids in terms of this activity and what you're going to be doing for your homework is kind of boring because the only thing we've got to work with is that in a trapezoid, we should have one pair of parallel sides. So if you notice here, they've got these little red markings, okay, and that's to indicate that those two sides are parallel, okay? Their sides can be different lengths, okay? There's nothing about, you know, they can be equal in length, in terms of like these sides over here, these slanted sides. They can be equal, but they don't have to be. The only requirement of a trapezoid is that you have one pair of parallel sides. If you have two pairs of parallel sides, you're a different shape now. Okay? All right. So calculations. So I have these characteristics and how do I show them algebraically? So how do I write down math? Okay, write down numbers. That helps me prove to someone that, yes, I'm dealing with a square or a rhombus, or which shape do I have? All right, so a square. What you're going to do is you're going to find the lengths and the slopes of all your sides. So that means you're going to be doing some distance formula and some slope calculation. And then you're going to be looking to see, after you've done the distance formula, are all the sides equal? Okay, and then you're going to be looking to see that the slopes of the connected sides, are they perpendicular, meaning are they opposite reciprocals? Okay. A rectangle, same idea. Find the slopes and lengths of all the sides. Okay. The slopes of opposite sides are parallel. The slopes of connected sides are perpendicular. And then opposite sides are equal in length. So you'll have two answers, and you'll have an opposite side and then opposite side. So the lengths, the opposite sides are your lengths. They'll be the same distance. And then your opposite sides, your widths, those are going to be the same distance. All right, a parallelogram, same thing. Find the slopes and the lengths of all the sides. Opposite sides are equal in length. Slopes of opposite sides are parallel. However, slopes of opposite sides are not perpendicular or opposite reciprocals. If you have two slopes that are opposite reciprocals, that means they are perpendicular, you're not a parallelogram. A rhombus, you're going to find the slopes and the lengths of all the sides. Okay, and it says all sides are equal in length. Okay, now I know it says the opposite sides are not parallel or perpendicular. It actually should have said, the opposite sides are parallel. I need to fix that. Okay, so let's fix that. Oops. Opposite sides are parallel and not perpendicular. Okay, so opposite sides are parallel because remember it's a parallelogram. Okay, so that was a typo on my part. All right, from current slide. All right, a kite. You'll find all the side lengths. Your connected sides are equal in length. And it's not necessary to find slopes of sides because they're not going to be parallel or perpendicular. You're really just focused on side lengths. Okay. And then a trapezoid, you're going to find the slopes of all sides. Okay, because that way you've got four slides or four sides. Okay, two sides must have the same slope. Okay, so they will be the opposite sides. The other two sides must have different slopes. Okay, so you might be thinking, just trust me, when we get to an example, I'll show you what I'm talking about. Okay. All right, so that brings us to the end. So you've got the classifications. You should have an idea of what these pictures in your mind start to look like. And now when we come back in the second video, we're going to do actual examples. Okay.